Okay, now given the general form of an equation for an ellipse centered at hk, we want to express the equation in standard form. Step 1, we have to recognize that an ellipse described by an equation in the form ax squared plus by squared plus cx plus dy plus e is equal to 0 is in general form. Number 2, we have to rearrange the equation by grouping terms that contain the same variable, and then move the constant term to the opposite side of the equation. Step number 3, we factor out the coefficients of the x squared and y squared terms in preparation for completing the square. Number 4, we're going to complete the square for each variable to rewrite the equation in the form of the sum of multiples of two binomials squared set equal to a constant. So we have our constant times x minus h squared plus our other constant times y minus k squared is equal to our constant, where m1, m2, and m3 are constants. The number 3, we're going to divide both sides of the equation by the constant term to express the equation in standard form. So in example number 6, we're going to graph the ellipse centered at hk by first writing it in standard form. And the equation is given by 4x squared plus 9y squared minus 40x plus 36y plus 100 equals 0. And then we're going to identify and label the center, the vertices, the co-vertices, and the foci. So step number 1, we must begin by rewriting the equation in standard form. So we have 4x squared plus 9y squared minus 40x plus 36y plus 100 equals 0. We're going to group terms that contain the same variable and then move the constant to the opposite side of the equation. So we've grouped 40x squared minus 40x together plus 9y squared plus 36y, and then we subtracted 100 to both sides. In step 3, we're going to factor out the coefficients of the squared terms. So the x terms we can factor out of 4, and we're left with x squared minus 10x. The y terms we can factor out of 9, and we're left with y squared plus 4y, which is equal to negative 100. And now what we're going to do in step 4 is we have to complete the square twice. And remember to balance the equation by adding the same constants to each side. So this x squared minus 10x, we're going to write an n here. And then the y squared minus 4y, we're going to write an m here. So it's going to equal negative 100. But keep in mind that on the right side, we're going to have 4 times n, so it's going to be plus 4n. And then plus 9 times m on the right side. So now in order to solve for n, we're going to get 1/2 of b squared, which is equal to 1/2 of negative 10 squared, which is negative 5, and when you square that, it gives you positive 25. For the value of m, we're going to do the same. Take 1/2 of b squared, which is 4, so 1/2 of 4 is 2, squaring that gives us 4. And now we can substitute n and m into the third part, excuse me. So we have 4 times x squared minus 10x plus 25, plus 9 times y squared plus 4y plus 4, and that's going to equal negative 100 plus 4 times 25 plus 9 times 4. So we end up getting 4 times x squared minus 10x plus 25 plus 9 times y squared plus 4y plus 4 equals negative 100 plus 4 times 25, which is 100, plus 9 times 4, which is 36. And now we're going to rewrite them as perfect squares. So we're going to have 4 times x minus 5 squared plus 9 times y plus 2 squared, which is equal to 36 on the right side. And so now we're going to divide both sides by the constant term to place the equation in standard form. So we're going to divide each term by 36. So now we get x minus 5 squared over 9 plus y plus squared over 4, which is equal to 1. In step 7, now that the equation is in standard form, we can then determine the position of the major axis. And because 9 is greater than 4, the major axis is parallel to the x-axis. And therefore the equation is in the form x minus h squared over a squared plus y minus k squared over b squared is equal to 1, where a squared is equal to 9 and b squared is equal to 4. So the center of the ellipse is at hk, which is going to be at 5, negative 2. The coordinates of the vertices are h plus or minus ak, which is 5 plus or minus the square root of 9, negative 2, which becomes 5 plus or minus 3, negative 2, or 2, negative 2, and 8, negative 2. The coordinates of the co-vertices are h, k plus or minus b. So we have 5, comma, negative 2 plus or minus the square root of 4, which becomes 5, comma, negative 2 plus or minus 2, or 5, negative 4, and 5, 0. Now the coordinates of the foci are h plus or minus ck, where again c squared is equal to a squared minus b squared. So it's going to be plus or minus the square root of 9 minus 4, which is plus or minus the square root of 5. So the coordinates of the foci are 5 minus the square root of 5, negative 2, 5 plus or minus the square root of 5, negative 2. And so now what we're going to do is we're going to plot and label the center vertices, co-vertices, and foci and draw a smooth curve to form the ellipse as shown. So here we have our vertices located at 2, negative 2, 8, negative 2. We have our focis. So we have 5 minus square root of 5, negative 2, 5 plus square root of 5, negative 2. Our co-vertices is at 5, 0, 5, negative 4. And of course we have the center at 5, negative 2.